Hi everyone. In this video, I will walk you through the microservice backend architecture of this e-commerce platform, which is built using industry standard technologies and frameworks like Spring Boot, Netflix UX Server, Kafka, Redis, Elasticsearch, and many more. Also, we will have a live demo of a key API flows like login flow, admin flow, user sign-up flow, user profile management flow, and product purchase flow. The high-level design of the backend system looks something like this. The entry point to web/mobile client is the API gateway, which doubles up as a load balancer. For the requests that it want to forward to any of the microservices, it consults the service discovery. And we have a couple of microservices, which are user service, product service, search service, and others. We also have Kafka for distributed message queue. And we have a Redis cluster for global cache management. For payments, we have integrated our backend with the payment service providers, or call it as a payment gateways, like a Razorpay and the Stripe. For phone notifications, we have a couple of them. For email notifications, we have integrations with SMTP servers like Gmail servers. And for the SMS, we also have integrations with the Twilio. Why this project stands out? So there are a couple of points here. This project is scalable and modular design, built with a clean architecture following the industry best practices. So we have used solid principles extensively and the design patterns like a strategy design pattern, adaptive design pattern for the third-party integrations, and many more. We also have a secure and reliable systems. We integrated the OAuth 2.0 for the tokens. We used JWT, JSON Web Tokens. For database and caching optimization, we used MySQL. We could also use Postgres for different use cases. Along with that, for the global cache management, we used Redis for high performances. So the backend is microservice ready. When I say that, it's designed to scale seamlessly with the help of service discovery, which we used. Here is Netflix UX and the API gateway, which is again a Spring Cloud gateway. We also have advanced search capabilities as we integrated with the Elasticsearch for very fast searches, which supports basic keyword searches as well as advanced filtering. We'll have a demo on this, how basic filters and the basic searches and the advanced filters work. We have seamless integrations with a Razorpay and the Stripe for secure and flexible payment processings. The extensibility and the maintainability of the code base that we have built. We follow our robust design principles, as I highlighted earlier. We have strategy design patterns and the adaptive design patterns for third-party integrations, and we have also used some of the reusable patterns. And the last one I would like to highlight is this isn't just another backend project. It's a production-ready foundational project for any e-commerce application looking to scale and perform at the highest level. So under the user management, we allow users for the registration using their email addresses. We could also support the social logins. We have a secure login implementations. We have a profile management. Users can edit their profiles and update their profile pics and others. Users can also do a password reset as well as a password change functionalities. For the product catalog, we have the most important one is the powerful search feature that we have implemented using the Elasticsearch. And for the cart and the checkout, users can add items to cart. They can review the cart, and then after reviewing the cart, they can actually seamlessly check out and then make for the payments and then get the product delivered home. We have order management. Order management covers order confirmation, SMS, and the email notifications once the order is placed. Users could also track the order history, and they can track the delivery of the order. So coming to the payments, we support multiple payment options, which we have integrated with Razorpay and the Stripe, which supports the card, credit card, debit card, UPI, and net banking as well. We have authentication and security in place. For a password encoding, we use Beacon password encoders. For authorization, we use JWT-based authorization, as well as we support the OAuth 2.0 for login and the social logins. I want you to take a look at the low-level design of our system. We have a couple of class diagrams here as well. And you can find the link to this GitHub in the description below. Let's now dive deep into high-level design aspects like architecture of the system and the data flow diagrams. Architecture, we have built the architecture on AWS. We use AWS services across two availability zones for high availability and default tolerance. Let me little bit zoom in here. When the web or a client, mobile client, try to access our backend system, they first hit the Route 53, which is the Amazon's DNS, and the request flows to the Elastic Load Balancer, which is internet facing through the Internet Gateway. Let's say the request goes to the availability zone 1, and we divided the VPC, the virtual private cloud, into two sets, a public subnet and the private subnet broadly. Elastic Load Balancer, it forwards the traffic to the API gateway. API gateway forwards the traffic to the private subnet, and the private subnet is divided into two subnets again. For an app, we call it as an app layer subnet, and for the data, we have a data layer subnet. Once the request hits the app layer subnet, based on the request mapping, it will be forwarded to a corresponding microservices. We have a Eureka server here for service discovery. Coming to the data, we have MySQL for structured database. We have Elasticsearch for searching and optimizations. We have a Redis cluster here for a global caching. We have a Kafka for a distributed messaging queue. Since these two availability zones are on the same Azure region, so we also support synchronous replication between the two availability zones. We have mainly 5 data flow diagrams for this demo. The first one being the login flow. The second one is the admin flow, following the user sign up flow, user profile management flow, product purchase flow. Let's start with the login flow. The backend uses OAuth 2.0, and the grant type used is the authorization code. So here we have 3 parties involved in this login flow: client, user agent, authorization server. In our case, the postman is going to be the client, user agent is the web browser, authorization server is a user microservice that we have built. So let me quickly zoom in this. There are a couple of steps how this login happens. First, the client, in our case the postman, redirects user agent, the web browser, to the authorization endpoint with the query parameters, response type, code, client ID so and so, scope so and so, and the important one is the redirect URL. Since we're using the postman, it's a postman's redirect URL. So once the user agent receives this redirect, it reaches the authorization server with a GET request to the same endpoint. Once the authorization server verifies the client ID and the response type being the code, which in this case is the grant type, the authorization code, it verifies whether the user is already logged in or not. If not, it redirects user to the /login. Once after, user sends a post request back to the server with a /login by sending username password. If username password matches, it redirects user to the redirect URL that was sent in the request by the postman with the authorization code that you could see here. It's a GET request to the postman's callback with a code, authorization code. Now the postman receives this callback. In exchange with the authorization code, it requests for the access token. From now onwards, there is no involvement of the web browser. It's only the communication between the client, in our case the postman, and the authorization server. Now the request from the client to the authorization server is on the /token endpoint. A client secret, which is when set by client during the client registration. The next one is a grant type, authorization code, and the code that was just sent by the auth server. And finally, the redirect URL. Once the authorization server receives this request for the /token endpoint, it verifies the client ID and the secret, as well as the code that was generated just before. If all that matches, authorization server sends back the post request to the callback URL on the postman with the parameters in the body. The parameters include access token, which in this case is a JWT access token. A token type is a bearer. The expiry is in, and the refresh token if it is set, and the scope for the profile. So let's now get to the demo. So I've just opened the postman. I have a collection here. Let's go with ecom microservices and go to the authorization tab. We are using OAuth 2.0. We would want every request to include this authorization bearer token in the request header. So I'm going to select the request header, can be URL as well, but most of the time it's a request header. I'm going to configure for the new token. So the token name that I'm just including is the email address of the user. In this case is admin.ecom@gmail.com. This is the admin user. Grant type is authorization code. The redirect URL, which is a callback URL to the client, which in this case is the postman's callback URL. We have authorization URL /authorize. For the access token URL, we have auth2/token. The client ID, client secret, scope. So I'm going to request for the new access token. Let me click on this. Now I get the sign in page. Now I input the username, the password, admin, enter. Authentication complete. I can proceed, and then I can use this token for the request. Admin flow. So let me quickly zoom in this. As a part of our admin flow, the first request is a login flow, which we just saw. We'll start with the second one. Create a new role. Admin can create a role. Admin can create categories. Admin can create products. Once a product is created, since we are trying to utilize the Elasticsearch for searching capabilities, so the product service pushes a message to the Kafka topic, which is named product service.product created. So once a product is created, a new message is put into the Kafka topic. Now the search service subscribes to this Kafka topic and then reads the message that was put by the product service. Once it does, it creates the product into the Elasticsearch database and it indexes it. So let's quickly jump into the Postman to see this in action. So let me select the create role. Since I'm already logged in, I would try to use the authorization code. I'm just trying to inherit it from the parent. When I hit a /roles with the HTTP method post, and the body would look something like this, I would want to create a role called logistic admin, and the description is so and so. When I hit send, we have 200 OK, and it says role created successfully. Let's just verify that. I go to this and refresh the database. I go to role, and you can see the role called logistic admin with so and so description is created. Now let's create a category using the /categories endpoint. Let's go to product service, create category, /categories for creating a category. The title that I'm going to provide is outdoor and travel. I want to create a category with the title outdoor and travel. Remember, the authorization I'm using is the OAuth 2.0, which I'm inheriting it from the parent collection. So let's hit send. Once it's done, you get 200 OK. An ID is generated for the category outdoor and travel. Now let's go to the diagram. We have a product service which exposes /products to create a product. Let's go to the Postman, create product. I want to create a product with the title hiking backpack and with so and so description and the price for that, as well as the category ID. So let me copy the category ID, which is a 23, for referencing it to the outdoor and travel category. So let's start with 23. So when I hit send, 200 OK. ID, the product ID is 229. The title is hiking backpack. The description so and so, price, also the category this product is assigned to, which is in our case outdoor, and the travel. So let's verify if the search service was able to pick up the message from the product created Kafka topic. I'll go to Elasticsearch UI. I go to indexes. I go to products and I search for hiking. Yeah, this product is now a document in the products index with the title, description, and few other parameters. Title, description, price, category, so and so. User sign up flow. When the user hits /users API, a user is created. A message is put into the user created Kafka topic, which are then picked up by two services, cart service and the notification service. The cart service will create an empty cart for the signed up user. The notification service will send a welcome notification to the user who just signed up. For the demo, let's jump to Postman. So sign up. User is going to hit the /users endpoint. Take a look at this authorization. So for /users, there is no authorization and it is public. Taking a look at the body, it takes name, email, and the password. Let me hit send. Yes, the user with the ID 52 is now created. As a part of the user creation flow, a card would be created. So let's go ahead and verify that. So let's go to database, card. Yes, the user ID 52, a card is created, empty card is created. So also an email notification would have also been triggered. So let me go to Gmail and log in with that user. Yes, I can see that there is a welcome message. Welcome to Ecom. Welcome to Ecom Sridhar Patil. Your account has been created. From, you could see this is coming from bizecomdelivery@gmail.com. User profile management flow. In this flow, user can reset the password, log into the system, change the password, as well as add a shipping address. Let's jump into Postman for the demo. Password reset request. This is the endpoint for the password reset. The email address is only the parameter for this request. So let me hit send. It's a 200 OK. The message says OTP sent to your email. Let me check my inbox. Yes, I have received it. It says password reset request. Your OTP is 9189. Let's go back to the Postman. Password reset confirmation. Now I'm going to input the token, which is 9189. And it's a put request. The body has only one parameter, which is a new password that I'm going to set it to party. So send. Yes, it's a 200 OK. Password is reset successfully. Now, as a part of the flow, user can log in. So let's test that. I go to authorization. This time I use a sign up window appears. I put the username, the password. I'm going to use the old password. Let's see how it behaves. Yes, it's a bad credentials. Now I'm going to provide the new password, which is Patil. Yes, the authentication is successful. And I have a JWT token here. So let's take a look at this JWT token. Yes, the payload looks something like this. The subject is the email address. The most important one is the roles, which is used by the resource servers, basically all the microservices, to just look at this roles and decide what are the endpoints that are allowed. Let's go back to the flow. Let the user change the password. Change password is only allowed if the user is logged in. So let's go back to the Postman. go to change user password. The endpoint is /users, the user ID and the password /password. Authorization, for a time being, I'm going to set it to no auth. Let's see how it goes. The body, the old password and the new password. I hit send. Yes. 401 unauthorized. The request is unauthenticated. Now let's try with the proper authentication with the old password and the new password. I hit send. Yes, the password updated successfully. Now I go back and try to re-log in. I use the old password. Let's see, PATIL. Yes, it's a bad credentials. I use the new password. Yes, I'm able to log in. Use this token. Now the user can add a shipping address. So add shipping address. The endpoint is /users, the user ID /shipping addresses. The body is with few address parameters: country, state, city, street, up, and the pin code. Let's choose the authorization. Let's hit send. Yes, 200 OK. Shipping address added successfully. Product purchase flow. Let's zoom in. Users can search product. Once they search the product and get the product ID, they log in to the system. They can add items to the cart. After adding items to the cart, they can check out the cart, which triggers the order service via the Kafka topic, which in turn triggers the payment service with the order created Kafka topic. The payment service interacts with the third party Razorpay or the Stripe payment gateways. Once it's done, it generates a payment link. User can check the order details by providing the user ID and the status created. The next step is to get the payment link for the order ID. Once the payment is completed, there is going to be a callback to the system from the payment gateways. Once it's done, the callback updates the payment status. If it is successful, puts it into the payment success Kafka, otherwise payment failed. These messages are now picked by order services and updates the order correspondingly. Once the order service processes, it generates messages into order confirmed or order cancelled. Now the notification service picks up the messages from order confirmed or the order cancelled. Based on that, an email is sent to the end user. Finally, the user can check the status of the order with the /order ID endpoint. Let's jump into the Postman for the demo. I'm using the JWT token that I've already generated. Let's go to search service. We have basic searches, 2 basic search, 3 advanced search. Let's go ahead and check for the basic search. Basic search are of get type and the advanced searches are of post type. For the basic search 1, I'm going to search for the product under the electronics and hit send. Yes, I have 200 OK and I have list of products that are coming from the Elasticsearch. Most important, there is no authorization required since it's a public URL. By default, we get first 5 results based on the order ID: 189, 190, 191, and 192. Now let's go to basic search 2. You can actually pass in query as well as the pagination request. I can set it to 0, 1, 2, etc. and the size for each page. I hit send. Yes, I get 200 OK. For the query electronics, 0th page, and has 3 items in it. So let me go and update the page number to 1. Now the ID should start from 92. So let's hit send. Yes, the ID starts from 92, 93, and 94. If I want 5 requests per page, I can set the size to 5, 94, 95, 96, 97, 98. 5 results for this electronics. Advanced search 1. The advanced searches use a post request with the following body parameters. The advanced search 1 has a query pagination, which is again a JSON with the page number and the size, and the sort bys. We can sort it by any of the fields. Currently, I'm sorting on price in the descending order. Let me hit send. Yes, I get 200 OK. The results are 190, 91, 92, 98, and 95. Since the sort by is applied on the price, we get the results in the descending order of the price. The one with the highest price is on the top. The gaming laptop, the smartphone, smart TV, digital camera, smartwatch, so on and so forth. I can set it to ascending and it's hand. Yes, I get the order in the reverse. The price, the lowest one being the first and the highest one being the last. In advanced search too, we can apply filters on the fields and the operator, choosing price as a field for a range from 1000 to 9999. The query is electronics with a 0th page and each page containing 20 results. I hit send. Yes, 200 OK. I have results ranging from 1000 to 9999. Since it is sorted by default on the ID, you see ID 189 coming first, 191, 94, 96, 97, so on and so forth. For the advanced search 3, it not only uses filters, it sorts based on price. Let me hit send. Yes. Now you can see the one with the highest price is on the top. 8514, 7654, so on and so forth. Once the user is able to search through the catalog, user can add an item to the cart. I want to buy noise cancelling earbuds with the ID 199 and mechanical keyboard 194. Let's go to add item. The product ID is 199. Let's say I want to buy 2 of them and hit send. Yes, 200 OK. The product with product ID 199, 2 of them bought at the price 8514 and the subtotal for 2 of the products is 17028. I want to buy one more, 194 and one quantity. Hit send. Yes, the product with the product ID 194 and the quantity 1 is added to the cart. Once the user added products to the cart, user can check out. This is an endpoint for product checkout /cart/checkout. This is a post request. Hit send. Yes, 200 OK. The status is success. The message says checked out successful. Let's go back to the flow. Once the user checked out the cart, user can get the order ID with the /orders endpoint by passing user ID and the status created. Let's go to get order ID. The user ID is 52. Status is created. Hit send. Yes, the order ID which is generated is 73 for the user ID 52 and the total is 24682. The status is created. Let's take a note on order ID 73 and let's go back to the flow. Now user can get the payment link with the order ID. Go back to payments, get payment link, /payments/link, and the order ID is 73. Hit send. Yes, I get the payment link. I copy the payment link, head to the browser, paste in the URL. Yes, it takes me to the razorpay.com. I provide few details. Hit continue. Choose the payment options. Input the UPI ID and hit continue. It takes a while. Yes, it will redirect to the redirect URL. And once it's done, I get an email confirmation. Order confirmed. Your order has been confirmed. Thank you for shopping with us. Order ID so and so, total amount. Now User can get the status of the order by hitting /order/order ID. /73 send. Yes, 73. User ID is 52. Total amount is so and so. The status is confirmed. Future enhancements. We'll plan to implement Saga pattern, which will ensure a data consistency across multiple microservices in the distributed transactions. We will implement circuit breaker pattern, which handles the failures gracefully without affecting the entire system. For inter-service communication, instead of a REST, we will plan to implement gRPC for high performance, low latency communications. Thanks for watching. I hope you enjoyed this demo. Stay tuned for more deep dives into scalable backend architectures. See you in the next one.